Hello, dear students. Today we are going to discuss a very important topic of ecosystem ecology, and this topic is all concerned about how energy transfer takes place in natural ecosystems. In the previous two parts, we discussed food chains and food webs, and there we came to know how energy transfer takes place. Okay, that means one organism eats another organism, and that organism in turn is eaten by another organism, and this is how energy and matter are getting transferred across all the trophic levels of an ecosystem. Okay, today our main focus will be what are the governing laws that tells you how energy transfer takes place. Okay, what are the governing laws that determine energy flow in natural ecosystems? And without consuming much of your time, let us move on to the energy flow. You know that in majority of the ecosystems, the producers are the plants because they get a continuous supply of light energy. Okay, and we can say that the sole source of energy in these in majority of the ecosystems on earth is sun, but there are some rare exceptions. For example, you have deep sea hydrothermal vent ecosystems where the sunlight cannot reach, and as such there are the photosynthetic sorry there are some chemosynthetic bacteria, and these chemosynthetic bacteria they utilize some inorganic compounds and produce their organic compounds. Okay, they utilize the energy which they obtain from the oxidation of inorganic compounds, and they produce organic compounds. Okay, that means in these ecosystems the chemosynthetic bacteria they form the first trophic level. Okay, you know that the sun's light the sun's light continuously falls on the natural ecosystems. Out of this instant radiation which comes from sunlight, out of this instant sunlight, only 50% or less than 50% of the energy can be utilized, and this amount of energy is known as power or photosynthetically active radiation. Okay, the rest 50% is not photosynthetically active, and hence we are only concerned about this 50% or less than 50% of sun's light. And interestingly, the plants they cannot use this whole 50% radiation. Instead, they can use only 2 to 10% of this power. That means only 2 to 10% of photosynthetically active radiation is utilized by plants, is converted by plants to chemical energy of organic compounds, carbohydrates, for example. Okay, and quite amazingly, you can appreciate that only this 2 to 10% of energy is running the whole biological world, because ultimately, directly or indirectly, all the organisms on planet earth they depend on plants. Okay, here you can see this is the schematic way which shows how energy is getting transferred from from sun to producers and then to consumers. Here you can see the sunlight is trapped by plants, and they convert this sunlight to chemical energy of organic compounds, and then the plants are taken by herbivores, and energy and matter are getting both transferred and then to primary carnivores, secondary carnivores, and so on and so forth. Okay, this is the simplest way energy is getting transferred. We have already studied these things in the food chain. Our main concern is what are the governing laws. Okay, are the laws of thermodynamics strictly followed in ecosystems or not? Okay, first let me tell you something about first law of thermodynamics. First law of thermodynamics. First law of thermodynamics says energy cannot be created or destroyed, but it can be transformed, okay, from one form to another form. Here you can see the sunlight, which is the physical energy, it is getting converted to chemical energy. Okay, you are not either creating energy, you are not either destroying energy, but the only thing is the physical energy is getting converted to chemical energy. Okay, okay, the ecosystems they are not exempted from the second law of thermodynamics as well. Okay, let me first of all explain you what is the second law of thermodynamics. Second law of thermodynamics says a system goes in that direction which is accompanied by decrease in energy and increase in entropy. That means every natural system, every system tends towards increasing disorderliness. आपने ये केमिस्ट्री में पढ़ा होगा ठीक है. I am saying that the energy flow in ecosystems, it is in line with the second law of thermodynamics. Let me make you more understand it this way. You know that every ecosystem needs a constant supply of energy to function, to synthesize the organic compounds, molecules they require. And this energy input, it counteracts the universal tendency of ecosystems to increasing disorderliness, or you can say increasing entropy. ठीक है, मैं आपको एक एग्जांपल दूंगा. Just like an organism, if an organism is not supplied with food, that means you are not giving energy to the organism will move towards disorderliness, or you can say increasing entropy, and the organism will die. For maintenance of organisms, they need food to stop themselves from reaching the equilibrium, from reaching the highest entropy state. And same is the case with natural ecosystems. If the natural ecosystems they are deprived of energy, the ecosystem will die out. Okay, the ecosystem will die out. Or in other words, you can say that the ecosystems, they maintain order, they prevent disorder by gaining energy. And when they are gaining energy, their order is maintained. They use this energy to maintain their order. But on the other hand, the source where from they get the energy, the source gets disordered. Okay, the source gets disordered, but the system gets ordered. And overall, if you will see, the whole system plus surroundings, it gets disordered. Okay, that means the energy flow, it is not going according to the second law of thermodynamics, because both the system and the surroundings, okay, the surroundings gets disordered and the system gets ordered. Okay, system gets ordered by gaining energy. But the sum of these two is that the whole system plus surroundings, it gets disordered, which is second law of thermodynamics. Okay, I will repeat. You have an ecosystem, and that ecosystem continuously gains energy and it maintains its order. It prevents itself from reaching highest entropy state. But the source from which the ecosystem gets energy, that source gets disordered. Okay, and the disorder in the source is much more than the order in the system, and overall you can say that the disorder has increased, and this energy transfer is not going against the second law of thermodynamics. Okay, one important point that you have to note is the quantity of energy reaching successive tropic levels, it decreases due to the following reasons. The first one is a part of the energy is not utilized by the organism. Okay, that is not utilized by the organism is lost as heat. Okay, as you move towards the higher tropic levels, the amount of energy goes on decreasing. It is because of two reasons. A part of the energy which is not utilized by the organism is lost as heat. ठीक है, जब एक organism energy gain करता है, वो इस whole energy को अपने आप में नहीं समेटता है, बल्कि कुछ energy इसको maintenance के काम आती है. ठीक है, a part of energy is lost as heat, and another part of the energy which an organism gains, it is used in the process of respiration. ठीक है, it is used in the process of respiration. So you can say that as you move towards higher tropic levels, the amount of energy reaching those tropic levels, it gets decreased. ठीक है, and this was first of all shown by Lindemann, and he proposed a law which is known as Lindemann's 10% law, or Lindemann's thumb rule. And this rule says that only 10% of energy present at any tropic level is passed on to the next tropic level, and the rest 90% is lost. ठीक है, For example, these are the plants, these are herbivores, you are having primary carnivores, secondary carnivores, and so on and so forth. Okay, from this tropic level to that tropic level here to herbivores, only 10% energy will flow and the rest will be used by these plants. Okay, and the rest will be used by these plants for their maintenance. That means they will use the rest as the respiratory substrate, and some will go out to the environment as heat. And that is why when you are only getting 10% here, you will get here 10% of this 10%. Okay, and as you move towards higher tropic levels, the amount of energy reaching these tropic levels, it goes on decreasing. Okay, let us explain this with the help of a simple example. For example, in accordance with 10% law, if you have 1000 calories kilocalories of solar energy in a plant, अगर एक प्लांट ने 1000 kilocalories energy trap की है, what will be the 10% of this 1000? It will be 100. That means the herbivores will only have 100 units of this energy, 100 kilocalorie of this energy, because the rest energy, that means 900 kilocalorie, will be lost by the plants. Okay, some will be lost as heat and some will be used in maintenance, I mean in respiration. Okay, and then what is the amount of energy that primary carnivores are going to achieve? It is 10, because 10% of 100 is 10. Okay, and the rest 90 kilocalories will be lost. Okay, these will be used in respiration, and the secondary carnivores will get only 1 kilocalories, and so on and so forth. It means that as we move from lower tropic levels to higher tropic levels, the amount of energy reaching these tropic levels, it goes on decreasing. This is popularly known as Lindman's 10% law. Okay, this is all about the energy flow in ecosystems, and next time inshallah we will start with the concept of ecological pyramids. Till then, God bless you. Thank you all.